Hi, good afternoon, all of you.
Good afternoon, sir.
Okay, how many of us are there today? Okay, and people are going, there are three, five, okay. So I'll start my session. I think it is 2-2 now. 2 minutes, we are 2 minutes past 2 o'clock. So if you all remember, so do you all listen to me? I think all of you, do you all listen to me? You can write me yes or no. Okay. Okay. How's the volume? I think it should be, in my previous sessions, my volume levels were not good. Actually, I detected in my last session. I think this time the volume should be able to listen properly. So if you remember, in my last session, we had discussion on correlation and as well as simple linear regression. I explained you how to perform the simple linear regression by using a package called SciPy strats. Close it. No problem. Close the door. Okay, we had the NumPy, SciPy, pandas, and I used the pandas to import the datasets. These are all abstract. They are all similar to datasets. I just created these datasets inside Calci. And you may be having datasets with you. You should use your own datasets to perform. So I also told you how to interpret the regression outputs. You'll be having a slope, intercept, and then p standard error, something like that. We just have to pick up the p-value and interpret the regression fit. This p-value is for f statistic. And then you got, I told you how to put all of them into a regression. So today, I'm just going to show you how to create a plot based on this information. We have slope and intercept. So what we do is that, what is the data which we use? This one and this two, right? X comma y. The first one is x and the second one is y. Now creating a plot. I'll write it as regression plot. Sorry, this is not okay. Okay, then we are going to matplot. I think matplotlib inline. Am I right? I don't know. You have to tell me. Matplotlib inline. Yeah. Now I'm going to create a figure. Whenever we use the matplotlib, we have so many ways to plot data. You can create visuals. You can straightaway go and use matplotlib. I think I should use import matplotlib pyplot as PLT. Okay. And now what happens? You can straightaway plot PLT plot. Now data, that is just going to be this one and this two. So this way, if you do, then that is going to yield the data is not defined. Okay. So run all. Nothing is wrong. Yeah, I think there is real CSV the problem here. Let me troubleshoot this problem and come back to this thing that I think we should go to the last error file, reading the file, not exist. High data CSV, why? Why did I not have this? I think in document itself I have my folder in which I should have high data CSV. Let me go to the properties. I'll choose this one, okay? Instead of in previous section I used something else. What happened?
Perfect. You don't need no pillar.
So this one I am not able to delete. Yeah. Shall we delete? Control. Yeah. Boom. No. Yes. I think now it came. Now. Okay. I think you see here it is linear. I mean, it's a straight line. When you plot these two, you can also make plot dot x label. I think label label. It is x and control C y label. Y label it is 1. Okay, and let me execute this. X label is not there. Set x label. Set x label. Set y label. Okay. So again there is has not a good set x label. Okay, I think I have to. Shall I use, there is a label, I'm sure. Though it shows not like x comma. So there are other ways. I am going to do the same thing in a different way. See, take and ax. It is called axis. It is not axis. Axis. It is not axis. It is called axis. Axes axis. Now PLT subplots. So this is actually an art. We have to now whatever the property that we are going to define for this plot should be done through AX. AX now plot, so make a plot. It's just like PL2 plot. Now instead of PL2 we are using AX. X comma Y, and I'll just leave that. No, we can do many things here. AX again plot, and this is a plot upon a plot. It's an overlay. We are just going to make an overlay on the base plot X, and here what happens, we have an intercept, we have slope times X, right? Here I enclose these two with a bracket, and then I'll just leave. Okay, now let's see what's going on. Now, yeah, I don't need to make, let's see, X is not defined, yeah, because data, plot data, this one, that is X, and this is data, this 2, right? And then here instead of X, data, this 1, data, this 1, and then here instead of X, let me copy. Why I'm writing, I don't know. So now press enter. So you are not just going to get within. You have to do that something as well. So this is not the way we get. I think we had to get something went wrong here. Line width markers is, shall we say, uh, okay, shall we delete this and see what's going to happen? Okay, there's an inverse relationship. Is it so? I don't know. Now, if I say, for example, I comment this, and I say control. Now, let me comment this, and let me see. Here the problem is, it is not plotting just like this. So PLT plot is not AX plot. It is something different. It's not plotting exactly right. Shall we go for scatter plot or scatter? I think to some extent it is okay. Now let me put AX. Yeah, this is a regression line. That's okay, fine. Now it looks good. It exactly looks like, shall I put, I want to put the color somewhere. Color is equal to red. Is it? Yeah. Now you see this is a regression line. There is a slight inverse relationship between, it's a straight line, right? But you see the scatter, actual plot is between, the actual plot is like this. There's a straight line. This is a straight line. Isn't so? There is, I don't know exactly. So this is actually the plot between x comma y. This is a straight line. Distribution. Whereas regression is different. You see here I plotted. First I made a scatter diagram. And if you see the scatter diagram, actually there is a pattern kind of thing. See here, it's a non-linear. And now through that, there is a slight, decline. The x comma y, both of them decline slightly. Now, if you want to go for here, I think set x level. Your x level will not work here. X, just one. Just one. And y level is this two. Set y level, I guess. Now let's say, yeah, this one, this two. Something like this. So this way you can create this is a regression line. The line which you are saying. Let's go back and see where is the intercept. I think here. Intercept is minus 0.01. That is here. I think that is not intercept. Intercept should start from 53 times x. The x value 53 times here it is starting times x. So it starts here and okay. So if you get any doubt, like whether this is correct or not, let us do one more. There is a library called. This is not exact way of creating the regression plots, but you can still make a regression plot in this way, and you can just incorporate that inside your. If you think that this is a report, then you can make your regression plot in this way. But there is a library for regression. If you really wanted to have in a scientific way, like if you want to plot your regression lines in a scientific way, then you got where is the boss? Mr. Yeah, there is a library called Seaborn. Let me show you. Import Seaborn as SB. Okay, I already installed just like this. Say, suppose how to install pip 3 install Seaborn, something like this. So I already have that, I guess. Pip 3 shows Seaborn. Now it will be able to show. Otherwise, that is the shortest way. Or pip 3 list get Seaborn. Now the rest of C1 here is C1. There is C1. So this way you can just see here C1. So like this you can verify if you have C1 in your computer or not. So now the easiest way is to use the matplotlib pyplot with the help of C1. There is a method called write plot. So I'm going to show you how to do that. And now import, I already imported matplotlib, I plot as PLT, I think. PLT? Yeah, PLT. Now we are going for SN set. Yeah, color. This is not important, but you can even do without this. But no, it is SB set. It is not SN. SB set color code. I'm just trying to define a parameter for our. Now the data set is data. We have AX is equal to SB, and then reg plot. Just right away this data. List one, list one, and then this two. Okay. So now you should be. I think we have the data is equal to data. That should be there. Now PLT, yeah, it has come. I don't need to. You see here, same. So actually, when I was talking, I think many of you must have. Let me see how many of you are there. Yeah. Oh, come on. Yeah. Okay, then I allowed everybody. Now you see, actually, when I did manually, so this is actually I did it manually. I plotted the regression line over the data manually with my own knowledge. Then I suspected that this may not be the regression line. Why I suspected? Because the intercept, this value should go somewhere in minus. So I thought actually I have conventional wisdom. Let's see, minus, this is a, and this should be something like this. Yeah, of course it is correct only. It's not intercept. See, just because if you have intercept like this, it doesn't mean that the while the line passed through minus. Actually, this is a mass. The very first value is going to be 53 times of x minus 0.01. So obviously, the line can start from here. So this is actual relationship, and this is a regression line which I did manually. Now I want to cross check my regression analysis with the help of a package called Zebra. So you can plot manually with matplotlib. If you, this is a way you can cross check your plot with Seaborn. Seaborn is a very nice package in which you also have quite a few other statistical techniques. In case if you are interested, Seaborn documentation, something like this. There is some noise. Somebody is talking. Yeah, admit. Mute all. I'm muting all. So you see Seaborn documentation, statistical data visualization. So it is not only for the statistical analysis, you can also, Seaborn is actually meant for visuals. You see there are quite a few other, I think you are able to see my browser. There's a wonderful Python library. Actually it is not there in your syllabus, but as I am talking about regression, I also would like to show you how to, this is the only way I can show you, I can talk to you as how to plot the regression data. So whenever you compute intercept, slope, and other information related to your regression technique, then you can just make a plot in this way. But in R, you have 4 plots, not like this. You have that and all you have to manufacture yourself. In Python, Python is meant for developers. Okay, it is not for you can develop an application. So that way, this comparison never exists. I cannot compare Python with R because R is the aim of R is entirely different. The community and the way statistics is performed in our community is cannot be compared with any other community. So Python, the aims of Python is different and R is different. R has straight away, so you can just carry on your data straight into the analysis. But in Python, it is not like that. Everything will be done in bits and pieces, so that those pieces will be aggregated. You can compile all those pieces. You embed each of those pieces in your application separately at different places. That is actually the idea behind the R. So now I'm showing you how to perform the simple regression and also make the visual. Now what we do, I'll explain you a particular topic called logistic regression. Okay. This is another important topic which we need to discuss, and after that I will straightaway go to. Now it is time 2:21, so I would like to finish my session well before 2 o'clock. Okay, because My I have only one laptop in my home. I have two laptops, but one is not working, and this laptop is used by the entire family. So my kids need this laptop at 4 o'clock. So I can't afford, 2 o'clock, can't afford to go ahead of. Now I'm going to talk about logistic regression. So what is this logistic regression? You just go to Wikipedia, logistic regression. So there are a few statistical techniques which falls under a particular area of operations called generalized linear GLM. We simply refer them to GLM. There is logistic, probabilistic regression, and there is MANOVA, and there are binomial regression, there are ordinal regression. There are many types of regression. So if you use logistic regression Wikipedia, then you will be redirected to a page where you'll find all the methodology related to logistic regression. This reading logistic regression is really very interesting activity. You have so many things to read from here. This is the methodology behind logistic regression. So I mean, before I talk about I don't need to talk about the methodology because I'm sure you'll be confused, and you need to have some. If you have read all those aspects in your previous term, then it may be very easy for me to talk about this methodology. It is just a kind of linear regression. It's not simple linear regression. It's a multiple regression model where the dependent variable is dichotomous. Like you have y is a dichotomous variable in which you have two responses, just like gender, male, female, yes or no, educated, uneducated kind of thing. Whenever you find kind of response variable which is dichotomous, which means two responses, then we'll model such relationship, like the relationship between the, especially when the dependent variable is dichotomous and you have n number of independent variables, then we'll go for the logistic regression. This is actually the form of the logistic regression. You see here you got log p divided by 1 minus p is equal to beta naught, beta 1 x, beta 2 x2. So this x1, x2 are independent variables. And here this log p by 1 minus p actually represents the independent x1, x2, all the variables which are there at RHS, there are independent variables. And this particular expression, log p by 1 minus p, is actually log of y given a response, male or female, given y. I mean, probability of male or female given y, something like that. Given an expression just like something, left hand side you will be having a ratio of the success divided by failure is equal to something like that. That is how we define. When it is actually a logistic regression, which means the dependent variable must follow the logistic. It should be a logistic distribution. So well before performing this logistic regression, we have to prove that the independent variable follows logistic distribution. Sorry, dependent variable need to satisfy the logistic property. Then log y is equal to beta naught plus beta 1 x plus beta 2 x. That is actually so y is actually the dichotomous. That is why you say p of probability of male given y, probability of female given y. That is what is the expression. Now you see when you take anti-log, inverse log, both sides, then this becomes e to the power of something like that. So p by 1 minus p is equal to b to the power of beta naught something. B is actually it is not b, sir, it is e. Sorry, e to the power of beta naught plus beta 1 x1 something, e to the power of x. Y is equal to log y is equal to x, then y is equal to log x. I think I already have. Why should I confuse you? I can paint program. I can just I don't know if you are able to see my paint program or not. I will try to share. Here the documentation is not clear. Come on, my laptop became all of a sudden slow. So it goes something like this. Suppose if you have y is equal to a plus bx. I think all of you are able to see my paint program, right? Or if you are able to see. Somebody is waiting for me. Are you all see? Do you all see my pen program? When I open a whiteboard. Hello. Hello. Do you all hear to me? Yes or no? Do you all see my paint program? Whiteboard. Okay. So now what happens? This y should be log 2 base 2. Log y is equal to a plus bx. So this is actually the expression. Now when you take log of now e to the power of a plus bx. So this is what is given in Wikipedia. Now this y is a dichotomous variable. That is why we said probability of a response male given y, something like this, male or female. Okay, let me think. Probability of y. Suppose if it is a gender, then probability of male, comma female given y. So that is how we represents this p is the e to the power of a plus bx. Now what happens is this p will be represented with help of this is actually the maximum likelihood ratio. This is called the probability of this is actually the there is a lot of theory behind this. I may not be able to explain you. This is actually the best estimate. Best estimate of y. We are estimating a value of y for given model. Given this model, something like this. Now what happens? This is a maximum likelihood ratio for this probability of m comma f. That is going to be p by 1 minus p, which is equal to e to the power of something like that. We represent this is actually the theory behind logistic regression. Now let us go back. I just wanted to tell you this because it is not